Well, welcome to Click for IB Biology in the series of videos concerning ecological stability and change. In this particular video, we're going to look at mesocosms, which are experimental methods in the experimental study of the factors affecting the stability of ecosystems. Down in the description, there's a blank PDF that you can annotate with your own notes as we go along, and there you'll also find links to 10 questions with the answers so that you can check your understanding of the topics that I'm about to present. David Latimer in 1960 built his own mesocosm, meso meaning middle and cosm meaning world. This is a term applied to creating an artificial model of an ecosystem in order to determine and to study the stability of those ecosystems. Mesocosms, whether at the small scale here, which are actually known as terrariums, or on the larger, more experimental versions that I'll show you in a moment, overcome the problem of studying the natural environment where scale, the size of the ecosystem or biome, is very difficult to monitor. Indeed, there will be factors in the natural environment which are uncontrollable, such as weather patterns, precipitation, and temperatures. The complexity of artificially created mesocosms allows that aspect of stability and change to be controlled and monitored. So like any experiment, the idea with mesocosms is to be able to control and evaluate and experiment with just exactly what each of the factors do in contributing to ecological stability. On a more academic level, this image shows a mesocosm, experimental work, being done in a marine environment and is actually taking place in Korea. You can see that the experimental setup is in the natural offshore waters, the inshore waters rather, and that these net systems are setting up isolated chambers as demonstrated in the diagram above. Each of these chambers, as you can check out with the key here, attempts to control and change the factors which may be affecting those ecosystems within the nets, those mesocosms within the nets, and are monitored using probes and investigations by the scientists, and then their data is presented in graphic form like this. In this way, the experimental scientist is able to evaluate on a smaller scale just exactly which factors are dominant, which are less important, and how the environment responds to particular changes. Our next video in stability and change, the link is appearing just in front of you now. A chance to subscribe to the channel, please, that would be much appreciated, or a like would be good. And on the right hand side, there's the playlist for this particular topic on stability and change in ecosystems.